So I think it's gonna work. Okay. So I am recording this for the other classes, so I'm not going to be saying any names. But what we're starting now is we're starting a new unit, I guess. This is going to be Unit 3. Unit 2 was on scientific notation. We didn't take a test over that. We just did a couple of assignments and moved on. But this one is going to be a pretty big one. And our first lesson today is about ratios. So, have you ever heard of a ratio before? Yes. Not asking if you know what it is, because a lot of times we hear about things. We hear these terms, but we may not know what it means. But y'all have heard of ratios, right?
Yes.
What about proportions? Have you heard that word? Proportions. Maybe? Okay. So this everything that starts with a 3 is going to be about ratios and proportions. Okay? Today I'm starting off with something that's pretty easy, but I have to start off with it that easy so that we can build to the higher stuff, the more complicated stuff. So you might think a lot of this is easy. If so, that's good. So in everyday terms, we would say a ratio is the same thing as a fraction, okay? But that's not the real definition of a ratio. We're going to write a few definitions today, okay? So make sure you get these down. So the first one is the definition of a ratio. It is a comparison of two quantities by division. A ratio is a comparison of two quantities by division. Okay, so I want you to draw 3 rectangles here, like I'm fixing to do, and try to draw them about the same size. Just kind of eyeball it. All right. Didn't do too good on that last one. All right, so this first rectangle, I'm going to cut it in half. And I'm going to shade one side of it. Okay. And we would say we have shaded 1 out of the 2 squares. Right? So we would say this is 1/2, or 1 out of 2. The second rectangle I'm going to cut into 4 pieces. So I'm going to cut it in half, and I'm going to cut those in half. So I've cut it into 4 equal pieces, and I'm going to shade 2 of them. So we would say we have shaded 2 out of the 4. But what do you notice about this shaded portion and this shaded portion?
They're split.
Well, this one is the same as this one, or excuse me, this one is the same as this one cut in half, right? Wouldn't you say that if we measured this one and all of this one would be about the same, right? Okay. And on the other rectangle, we're going to cut it in half, and then we're going to cut our halves into 3 pieces. 1, 2, 1, 2, 3, like that. So this rectangle has been split into 6 portions, and we're going to shade 3 of them. So we would say we have shaded 3 out of 6, exactly. Now, these are considered ratios here. 1 out of 2, 2 out of 4, 3 out of 6, but we know those are fractions, right? Now, we also know, hopefully, that this shaded area, and this shaded area are about the same. If we drew our rectangles to be the exact same, they would be the same, right? What this means is 1/2 is the same ratio as 2/4 and 3/6. Okay? What we're looking at here is we are looking at the ratio of shaded area to total area. a lot of times when you're talking about ratios, you're looking at a portion of a whole. So like on this one right here, the shaded area was 1, the total area was there were 2 blocks, right? So we shaded 1 out of the 2. On this one, we shaded 2 out of the 4 total. And this one we shaded 3 out of the 6 total. Okay? Okay, this part right here is the main thing that we're going to talk about today. Ratios that make the same comparison are equivalent ratios. For example, 1/2 is the same comparison as 2/4. So what that means is these are equivalent ratios. What word does equivalent remind you of? Equal. Okay, that's literally just a fancy way of saying equal. All right, so anytime you hear equivalent, that means equal. So what I'm saying, this definition here, all 3 of these ratios have the same exact comparison. We're comparing exactly half. So all 3 of those are equivalent ratios. Okay, another thing that we need to make sure we know is there are lots of ways to write ratios. A ratio can be written lots of ways. Probably the most popular way to write a ratio is just as a fraction. So sometimes we write our fractions like this, A over B. Normally we probably write our fractions like that. These are the 2 most popular ways to write ratios, but you can also see them written with a colon, like this, A to B. And that's how you read that, you say A to B. Sometimes you might even see your ratio written out in words. It would actually say A to B. In math, we don't usually write things in words, we usually use symbols. So these first 3 are the normal ways we would do it, and most of the time it's one of the first 2. One of these 2 options. And I know we're taking a lot of notes today, but we have to do this to kind of get prepared for all the other things we're fixing to do. But we are almost maybe halfway done. Okay, next thing. Since ratios that make the same comparison are equivalent, and this sentence right here, or this part of the sentence, comes from this definition right here. Ratios that make the same comparison are equivalent. Since that is the case, they all reduce to the same value. We know what reduce means, right? For example, up here, we know 2/4 is the same thing as 1/2, right? That's so high-pitched, I don't like it. But we know 2/4 is the same thing as 1/2. We would say 2/4 reduces to 1/2. When you reduce something, you take it to its smallest simplified form. Okay, for example, let's say we have a fraction 3 out of 15. 3 out of 15. When you're reducing a fraction, what you're doing is you're asking yourself, out of these 2 numbers, are they both divisible by the same number. 3 and 15 are both divisible by 3. So when you're reducing something, you're dividing them by the same number. What's 3 divided by 3? I know, we're writing a lot. We're almost done, though. 3 divided by 3 is 1, right? 15 divided by 3, y'all know that one? It's 5. What this means is that 3/15 reduces to 1/5. It's equivalent to 1/5. What this means is if I drew a big old rectangle and I cut it into 15 portions and shaded 3 of them, it would be the same as shading 1 out of 5 portions. Okay, so anyways, reducing, that just means they're equivalent. Another example is, say I have 2/10. Both of these numbers are divisible by 2. What's 2 divided by 2? Any number divided by itself is 1. 2 divided by 2 is 1. What's 10 divided by 2? Y'all know that one? It's 5. So what that means is 2/10 reduces to 1/5. Now, to blow your mind even more, if this fraction equals 1/5 and this fraction also equals 1/5, what do you think that means about these two fractions? They're equal to each other. Okay, think about it. If this is the same thing as 1/5 and this is also the same thing as 1/5, those two have to be the same as each other. Okay, that's what that means. Okay, so any ratios that are equivalent means they reduce to the same value. If this reduces to 1/5 and this reduces to 1/5, those have to be equivalent. That's what that's saying. All right, this is probably one of the most important parts of the whole lesson, okay? So make sure you write this down. How to make equivalent ratios. On the worksheet we're going to do in just a minute, there's going to be instructions that tell you, give me a ratio that's equivalent to blah, blah, blah. Okay, and it's a very easy process. Okay, say I take the fraction 5/3 and I want to make a ratio that's equivalent to this one. Okay, so here's my ratio, and I want to make another ratio that's equivalent to this one. Here's what you do. You're going to multiply the top and the bottom by the same number. And guess what? It can be any number you want. Yes, except for the number 1, okay? If I multiply this by 1, what's 5 times 1?
1.
It's 5. What's 3 times 1? 3. If I multiply by 1, I'm not changing it, okay? So what I'm going to do is I'm going to pick any number, and I'm going to multiply the top and the bottom by that same number. So normally we pick small numbers, like 2 or 3 or 4. If you start picking crazy big numbers, you're going to get crazy big answers. And we would like to stay away from that. So I would go with like 2. Okay, so I'm just randomly picking a number, and I usually pick 2 because it's an easy one. So what you want to do is you want to multiply the top by 2. What's 5 times 2? Alright, it's 10. 5 times 2 is 10, right? But I'm also going to multiply the bottom by the same number. What's 3 times 2? 6. So what I've done is I made a ratio that's equivalent to this one. Okay, it's that easy. You just pick a number. I pick 2 usually because it's an easy one. You multiply the top by 2, you multiply the bottom by 2. And what this means is this ratio and this ratio are equivalent. Okay?
Okay, so, are they gonna all be 2s?
No, they can be any number you want. As a matter of fact, on the worksheet I'm fixing to give you,
That's not what I
what I do is I say give me 2 equivalent ratios. So right now I've given you 1. Say I want to do another one. So I'm starting with the same number. If I want another one, multiply by a different number. So I just multiplied by 2, so I'm going to pick another number. And again, it does not matter what number. Think of a number besides 1 or 2. 3. All right, 3 it is. So we're going to multiply the top by 3. What's 5 times 3? It's 15. Okay. As long as we multiply the bottom by the same number, what's 3 times 3? 9. Boom. Okay. So what we've done is we took this original ratio and I gave you 2 new ratios that are equivalent to the original one. How do I know they're equivalent? Because the tops and bottoms were multiplied by the same number. Here we multiplied by 2. Here we multiplied by 3. And again, you could multiply them both by 50 if you wanted. You're going to get really big numbers over here, but that's okay. I think you're going to be able to do it too. You ought to be able to. All right, let's do another one like that. I know your hands are getting tired. We're almost done.
I can feel the muscle like right here moving.
All right, let's say I have the fraction 25 over 10. And I want an equivalent ratio. So, if I want an equivalent ratio, I literally pick any number I want besides 1. Again, if I multiply by 1, I'm going to get the same number. That's not going to help me, okay? I want a different number. So you pick any number you want besides 1, and you multiply the top and bottom by 1. So, what do y'all say? What numbers y'all want to multiply by? 3. All right. She likes 3. That's fine. So we're going to multiply the top by 3. What's 25 times 3? 75. So that's what's now going on top. And then we're going to do the same thing on bottom. What's 10 times 3?
Oh,
Boom.
This
This is going to be easy. Now, again, all this means is that this ratio is equivalent to this one. This one actually reduces to 25 over 10. Okay? Say I want to do another one because, again, on the worksheet, I'm going to make you do it twice. So, you go back to your original number. This time you multiply it by something other than 3. But not 1. If you multiply by 1, it won't change it. So we could do 4. All right, we got a 4 over here. And again, it literally doesn't matter. So she says 4, so that's what we're multiplying by. What's 25 times 4? Y'all don't know that one? What's 4 quarters give you? $1. 25 times 4 is 100. Oh, crazy. Okay. And then you do the same thing on the bottom. What's 10 times 4? 40. That's my answer. So what I've got, again, I gave you 2 different ratios that are both equivalent to this original one. And again, these numbers, where did they come from? Where did we come up with 3 and 4? We just picked a number. It doesn't matter. Okay, so that's the first part. The second part of the worksheet, right here, this part is, I don't know, some people thought this was easier than the other part. It should be a little harder, but some people didn't think that. So this is how to determine, this is the last thing we're going to do, if ratios, are equivalent or equal. This is going to be so easy, let me tell you. So on this part of the worksheet, I'm going to give you 2 ratios. I'm going to give you 10 thirds. and let's say 100 over 30. I've got two different ratios and I want to know if they're equivalent. Now technically there's a lot of ways you can do this, but here's what I want you guys to do. I want you to figure out what it's called the scale factor. And what that means is what number you multiply by. So you take your smaller ratio and at first you just look at the top and you ask yourself, 10 times what gives me 100? And listen, because it seems like you guys may not be great at your multiplication tables, which, who cares, it doesn't matter. We got these calculators for a reason.
You gotta cheat on there.
To help yourself.
Yeah.
So the question is, 10 times what gives me 100? What's the opposite of multiply? Uh-oh. Okay. Divide. Multiply and divide. Multiply and divide are opposites. Okay. So if I want to know 10 times what is 100, I'm going to go the other direction and I'm going to divide. You just do 100 divided by 10. That means 10. So what this means is 10 times 10 gives me 100. So what you have to do is you have to figure out what did we multiply by to get from here to here? They multiplied by 10. The question is it the same on the bottom? Is 3 times 10 30?
Yes.
It is, right? Okay. So what you're looking for is the top and bottom have to be multiplied by the same number. If that is the case, yes, they are equivalent. Okay? Yes, they're equivalent. I'm going to abbreviate. Now on the worksheet, I'm going to ask you how you know. This is how you know. You say, okay, well in this case, they're both are multiplied by 10.
I like the way it smells in here.
What does it smell like?
It smells like fall, like I can't explain it. I smell the smell, like I smell it.
Okay.
It's awesome.
I ain't got nothing in here, so I don't know what that is. Don't know what it could be. All right, let's do a few more of these. I want to make sure we have plenty of practice. So again, yes, these are equivalent because the top was multiplied by 10 and so was the bottom. All right, let's say my ratios this time are 7 over 8 and 14 over 15. All right, what you're looking for is you're looking for a number that the top multiplies by and the bottom multiplies by. So the first question is, 7 times what gives me 14? And if you don't know, you do the opposite, which is 14 divided by 7. 14 divided by 7? Two. This means 7 times 2 is 14. Y'all know that, right? 7 times 2 is 14.
What?
Y'all know 7 times 2 is 14, right?
Yeah.
Okay. Yeah, you just forgot it. Okay. So now the question is, what's 8 times 2? It's 16. And our fraction is supposed to be 15. Okay? So if 8 times 2 is not this number, this means no, these are not equivalent.
And where does 16 go?
Well, 16 should have been here. But since they gave us something else, all we're doing is saying, nope, they're not equivalent. If this had been a 16, the answer would be yes. Okay? But since it's a 15, the answer is no. All right. Let's say we have 3/4 and 12/16. And I want to know, are they equivalent? Are these equivalent? So, the first thing you want to do is you want to figure out 3 times what gives me 12. And if you don't know, you just do 12 divided by 3. 4. That means 3 times 4 is 12. So now I need to make sure the bottom is also being multiplied by 4. What's 4 times 4? 16, which is good. So what this means is they multiplied this one by 4 to get 12. They multiplied this one by 4 to get 16. That means, yes, these are equivalent because both are multiplied by 4. Again, when you're looking for equivalent fractions or ratios, you're trying to see if they have the same number that they're being multiplied by. Let's do a few more. Just want to make sure we got this. Let's say we have 12 over 9 and 26 over 7. So my first question is, 12 times what gives me 26? How do we figure that out? We're going to divide, right? 26 divided by 12.
2.
Whoops. I got 2.166666. What that means is 12 times this weird number gives me 26. This isn't an integer. We're looking for something that doesn't give a fraction. And that means 12 times nothing gives me 26, okay? Well, if that's the case, if this gives you a decimal right here, if this one doesn't give you the exact same decimal, 2.1666, we'll just abbreviate it there. I need to know what is 9 times that same weird number. So I'm going to type in 9 times. I'm going to just go up there and highlight that one so I don't have to type it all in. I use this arrow to go highlight it. Press enter. And if it doesn't give us 7, that's a problem. Did it give me 7? No. So again, this is like example 2. If we don't get the number that we're supposed to get, that means they are not equivalent.
Can I send this classroom?
Let's do one more. No.
I have to do extra work there, and I just thought about this, and
Well, next period I'm going to be teaching a different class, something different.
we can just push that away for the next.
All right, this is our last one that we're going to do. Now this one's a little bit different, but it's only because I have my bigger numbers first. So let me tell you the best way to do this. You go the other direction. Okay, so instead of saying 12 times what gives me 3, we need to start with a small number and go that way. We already did this one. 3 times what gives me 12? Do y'all remember? Okay, if you don't know, you divide. You go the other way and you divide. What's 12 divided by 3? Okay, so 3 times 4 gives me 12. Now I need to see, what does 5 times 4 give me? 20, which is what we wanted it to give us. So what this means is, if you go the other direction, 3 times 4 is 12, 5 times 4 is 20. Are these two ratios equivalent? Yes, they are. Why? Because they're both being multiplied by the same number. In this case, by 4. All right, let's start on this together just so y'all can see what I want you to do. And I'm going to keep on recording so that the virtual kids can see this too.
Oh, Jesus.
All right, now calm down. This ain't going to be that bad. So what we're going to do, on the first section up there at the top, all I want to know is I want 2 equivalent ratios. And right here, this is when you're literally just picking a random number, pick any numbers to multiply the top and bottom by. This is what we started out doing. Okay? So for that first section up there, just pick a number. So let's look at number 1. If I have 2 ninths, what number y'all want to multiply by? Don't pick anything too complicated. It don't really matter. 2. Yep, that's what I would go with, 2. So what's 2 times 2? 4. Okay, so we decided to multiply by 2. Now what's 9 times 2? 18. Boom, that's my first answer. Because it says give me 2, you got to do it again. You're just going to pick a different number. We already multiplied by 2, so this time we're going to go back to our original fraction and pick another number to multiply by. What do you want to do? 3 it is. And those are probably the best ones to always pick is 2 and 3, but you can pick anything. So she says 3. What's 2 times 3? 6. And what's 9 times 3? 27. Done. Move on to the next one. Okay, again, where did these random numbers come from? Y'all just picked some. You decided to multiply by 2, and then you decided the next time to multiply by 3.
Okay, so how did we get 6 and 27 again? I don't
She decided to multiply by 3. 2 times 3 gave us 6. 9 times 3 gave us 27. Maybe I should write this down. We did times 3 on this one. We did times 2 on that one.
Okay, because I totally forgot.
And again, we just picked random numbers, 2 and 3. All right, let's look at number 5. Here we're doing what we just finished doing. Tell me if they're equivalent. So what you want to do, you want to start with your smaller number. So we're going to start with this side. And I want to know 4 times what gives me 9. You do the opposite of multiply, which is divide. 9 divided by 4 gives me 2.25 times 2.25. Let me zoom in a bit. Okay. Now we need to see if 5 times 2.25 gives me 8. 5 times 2.25 did not give me 8. So does that mean these are equivalent or not? No, they are not. You don't have to give me a reason. Just have to say no. Look at number 8. Last one we're going to do together. You're going to start with your smaller side, which would be here. And I want to know 11 times what gives me 66. You're going to divide to figure that out. 66 divided by 11 gives me 6. That means 11 times 6 is 66. So now I want to know what's 9 times 6. 9 times 6 should give me 54. Did you type in divided by? Okay, that's fine. Both of them are being multiplied by 6, so that means yes, these are equivalent. And it says if they are, show how you know. You don't actually have to write it out. There's my reason right there. That's how you know this one's being multiplied by 6, and so is this one. Okay?